That's a stack of angle iron right there. I don't know how many pieces we got, but we got to drill holes in every single one of those. Looks like a great job for the flex. All right, guys, welcome back to the shop. So as I just showed you there, we have got a stack of angle iron that we're gonna have to be drilling some holes in. So what I have been doing today is getting our Flex CNC set up, ready to run the production run. You know, this is what usually takes the longest, is trying to get the programming done and getting the setup done and getting it proven. And once all that's done, it's gonna be, I mean, it's gonna take a while to drill them all, but it's a matter of just pulling them in and out, hit cycle start. It's gonna drill the holes. And I think it's gonna work pretty quickly through all of these pieces of angle iron. I am gonna get some help with this. Howie over at the welding shop is actually gonna be, I think he's the one that's actually gonna come in and run most of these, but what I'm doing is getting the machine set up, do a little practice on it, making sure the system's good. And I've got some solid carbide drills on order. They will be here in a couple of days, but for now, I'm using a brand new high-speed steel split point drill bit to drill these, to make sure that our program is right, that we're drilling in the right location. And then all we'll have to do once we get the carbide is modify our program for through spindle coolant, because I don't have through spindle with this drill. So we'll change it to through spindle coolant, change our feeds and speeds, and I think that was it. That all we'll have to do once we swap out to our carbide drill bit. But it's running really good. I want to go ahead and show you where we're at right now. I just did the first, so my idea behind this was actually running two pieces at one time, butting them back to back to each other, okay? So just like that. Never mind the stick out right here. These were all cut by the welding shop, but what we're doing is working off of one end, and everything is actually on center there. It's basically 4 inches from the end and 24 inches center line there, okay? So 5/16 diameter holes, and all that is a clearance hole for a 1/4 inch screw to go through. These are gonna be screwed into a building somewhere, is really all I know about it. So I'll show you the setup that we got. So we're making use of three of our Tico work holding vices. That's why I invested in so many. So we have 4 of them dedicated to the Flex CNC here, with a 5th additional if I need it, that's over on the KBC mill. I wanted to make a nice solid hard stop that we could bump these things up against and not have to worry about something moving. So this was the best thing I had, our big V blocks, just clamped it down, and that should work really well for that. So bump them into the end there, just push them up to the end and tighten them up. I'm gonna make sure that they know they just need to make sure that we wipe all the angle iron off the back so that there's not saw filings and chips that it's trying to crush in between there. But clamp them together using the 3 vices, it's going to be more than good. So we know that our tolerance from here to here is going to be spot on every single time. If it happens to be off just slightly in the Y direction on either one, it makes no difference, because they said that they're going to put these guys up there and they're going to run a screw in these holes. So if it's off a little one way or the other, it doesn't really matter. Main thing is center line this way. But I've already measured that, and that is about as close to being spot on as you can get it. So point is if the drill happened to move, or when you clamp these together, that they actually try to separate just a little bit as you clamp them together. If the Y position is not exactly in the center of that, it's not a deal killer, and it's no big deal. So I just drilled that. I'm going to show you guys the operation. And what I did is I just went ahead and grabbed 6 of them and brought them around here to the shop. And this is what we started with. Joe gave me this piece of aluminum right here to get the program set up with, because they didn't have these cut yet. So this was the first one that I drilled, and everything worked out good. They finished the saw cutting, so I grabbed 6 of them to get the program running and making sure we're ready to go. So From here, I'm just gonna go ahead and we're gonna get these other 4 drilled. I'm gonna show you that, and then afterwards, we're gonna have a little production run, and hopefully I'll get some fun video to share with you of this job. We'll probably get some time lapse, and you know, we'll put the camera inside there so you can see how it's gonna operate and everything like that. So let's throw a couple more in there and hit cycle start so you can see what it's gonna look like when we're actually drilling some holes. This will be my first time swapping out both of them, so let's see how this goes. May have to open the vise up a little more. We'll see. This is going to be the toughest part of the whole job, is the manual labor part of it. Just wiping the back of it off, make sure we don't have any chips. All right, we're just butted against our hard stop there, so we should be good to go. And we knew that there's going to be a good chance of variation in height, and I can tell these right here, so they may be bowed just slightly. So what we did, we set our Z, we come down 1/4 inch above our Z to start our feeding, just in case there is a variation in the height of the work pieces here. I can tell there's a little bit on this one, maybe about 1/16 of an inch or so. So one of these may have been bent a little bit. I think we're ready to run though. All right, let's go ahead and hit cycle start on our next 2 here. I'm gonna film this one so you guys can see the entire cycle time, which is actually not that long. This first pair that we drilled, it says 2 minutes and 18 seconds. So let's go ahead and run it again. And I'm gonna go ahead and bring our feed rate down when we first start, just to make sure that we are still good again. So that's gonna add a little bit of time to it. So we're gonna come up here to cycle start. Turn our feed rate down about 50% or so. Like I said, we got the feed rate down slow. I just want to make sure that everything's good. One more time here. Yep, there's our 1/4 inch. So I'm going to bring it up to 100%. We've got our feed set to 6 thou per revolution on the drill, by the way. And so it's going to be G54 is the back angle iron, G55 is the front, so it's basically working on 2 work offsets. And now this is going to be the last hole on the back side. We'll do a Y movement. That drill's working good too. When we were setting it up, I was wondering maybe jogging it back and forth in Y would be a little bit better or faster, but we found that it's actually faster to do 1 Y movement and all the other movements just an X. It sped it up just slightly. And once we get our carbide drill in there, this is going to go even faster. Now we're on the last hole. And after last hole, it's going to retract up in Z to home, and then home and Y, so that we can get in there to the vise and get our parts out. All right, there it is. So let's see how long this one took. 2 minutes and 5 seconds. So let's just call it about 2 minutes per run. Quick and easy. Some of our chips there. So the drill's doing pretty good. There's a chip that it's putting off right there. The hole looks good. It's got there's that guy off the back of the hole right there. So it's looking good, and I've already verified the first 3 that I did, measuring it out, and it is spot on. So this is going to work really well right here. So I think I'm going to go ahead and clean these up. We'll just blow them off. I'm going to go ahead and get the other 2 in there because Joe wanted to see this set up and running too. So I think I'm going to call him and see if he wants to come see the next pair being drilled. But I'm going to get some video of this, of the production run. We'll get the drill swapped out, and we'll give you guys some time lapse of this job. And pretty good production job here for the Flex CNC. So I'm removing the drill that we've been using to do our testing on drilling the angle iron there on the Flex. I got my carbide drills in, but this one has been working really well. So this is the Chicago Latrobe. It was a new split point, shorter length drill, and it is still sharp as a razor there. So it's really been doing good, but we're gonna go ahead and swap it out for our new carbide drill that's gonna finish off the whole job. This is gonna be our carbide drill that we'll be using for the rest of the angle iron. I've got 3 of them here. So I got these from Chris over at Coastal Manufacturing Solutions. He is a dealer for Dormer Promet. Hopefully these are gonna be some good quality drills. He highly recommended this one, said he's had really good luck with his customers with this particular drill through coolant. That's gonna be great. So we're gonna go ahead and get this guy installed in the Flex. All right, just getting her tightened up into the tool holder right here using our Heimer torque wrench. Got it torqued to the ER16 value. That's the chuck that we're using right there. All right, so that guy is ready to install, and we'll get it touched off. All right, guys, well, it is the next day. I am doing a spindle warm up there on the Flex, and I've got our new carbide drill installed there. I still got to set it, but we're letting our spindle get warmed up, and then we'll get the tool set, the proper length there. And then I've got 6 more pieces of angle iron here that I'm going to go ahead and run the test on and make sure everything's good. And once we get to that point, then we'll probably start running production. And as I said, Howie from the welding shop is going to come over, and we're going to work together. I'm going to show him how to operate the Flex, and he's going to do all the heavy lifting. He's going to manually load, unload, hit the button, and do that kind of stuff. So he's going to help out get this batch of angle iron done. Chris from Coastal Manufacturing Solutions, he was in here the other day, and I was talking to him about this. So he set me up with some carbide drills, and that's what we got installed there. So we got 3 of these 5/16 solid carbide drills through coolant. This is their Force X drill oil feed, so through coolant 3XD. All right, And he also brought me a catalog there so I can reference this when I need to look up some tools, but it also has your feeds and speeds in there too. So we've got this drill is going to be set at 460 surface feet per minute. That should be 5,623 RPM and a 10,000 feed rate, feet per revolution. So it's going to be moving. It's going to be going through those holes pretty quickly, which is what we want. That's what our drill looks like right there. If you look it up closely, it's about like that. So excited to see how this is going to work, and it should do pretty good. I've got 3 drills here, and hopefully one of them is going to get through the whole job, but I want to make sure I had some backups there just in case one breaks or whatever, you know what I mean. I also over the weekend I went ahead and topped off our flood coolant on the machine. The sump had actually, you know, a lot of the water had evaporated, so I needed to top it off. So we've got our master fluids coolant topped off in there, and used the digital refractometer. We got it at a Brix level of 8.5, which is right about where you want it, just a little bit over, but that worked out pretty good. That new coolant system that I set up with the Reelcraft reel, where I can pull the hose right to the sump, turn the thing on, it mixes the oil and the water together. Man, it's such a time saver and such a pleasure to be able to do that to top off our machine coolants. So that's going to take a few more minutes to get warmed up, and we'll show you how our first few test pieces work out with our new Dormer drill, okay? Okay, I have run 2 pieces of angle using our new carbide drill, and the drilling operation went beautifully. The holes are just absolutely gorgeous. I mean, they look like a reamed hole. Super fast for the drilling through there. So this looks like it's going to be good to go. I've got 2 more down there that I can drill as our test before we actually start the full batch. But something else I wanted to point out was that I was having an issue with the spindle when we first started this, and I don't know what it is, but one of the nice things about being able to contact Flex is that they can access this with TeamViewer. So they can get in here and control this just like if you're standing here and controlling it. So we had a couple of the engineers, the software engineers, running through the program as I'm standing here watching it too, and they were able to make a couple of tweaks and modifications and run some tests within the software there, and got it to where it was working like it was supposed to. But like I said, I'm not sure what that is. They're gonna look at it further. They did a copy of the software and some other things, and they're gonna go in there and see if something's wrong with our programming, or if there's something within the machine itself that needs to be adjusted or tweaked. It was when it was coming up to the RPM, something was happening where the machine was actually reducing the RPM, and so we aborted and went out of there. So it's running good now. But one of the great things about that is what I'm saying. I put my headset on and I call Aaron over at Flex, and we talk through this. They get on there, they have access to the program, and him and I can work together, or whoever on the other line, and communicate in real time and try to figure out whatever's going on. Same thing about teaching me and helping me and guiding me through this as well. It's really nice having them where I can talk to them and they can see the software while we're working through a program. All right, so I'm gonna swap these out, and I'm gonna show you guys in real time the cycle time, what it takes. I can't remember what it was. I forgot to look at the cycle time, but we'll see how long it takes to get our angles drilled with our carbide drill now. Let's send it. Really, the noise that you're hearing is just the material flexing. Super fast. We're at 1 minute. All right, it's going to go to home position and X. Z up. All right, cycle time 1 minute and 14 seconds. Not bad at all. So it takes us longer to get the pieces loaded and unloaded than it does to actually drill them. That is so cool. All right, well, that was my last two work pieces or test pieces. So I'm gonna go ahead and I'm gonna take this batch over there to the welding shop and get them stacked up. I think I'm gonna grab a few more to go ahead and run through these again and just make sure everything is good to go. But I think everything is gonna be working great for this job right here. I've got two more loaded up in the machine, so how about we give you guys a ride along for this one. You guys can see how it cuts in real time. We got you another camera set up in there, so hopefully that'll provide you a good perspective of the cutting action. So I moved it down here where it starts so I can get it framed in the camera, but I'm gonna move it back to the home position so you can see it from start to finish. So that particular run, we made it in 1 minute and 13 seconds. I think we've got this proven out and we're ready to run. I got two more there that I can run on my end here, and we'll get a couple little videos that we can share on the Instagram page. But other than that, next phase is actually bringing the whole bundle over here with the forklift and just starting making a production run on it. So I'll bring you guys back and show you a little bit of that action and how the whole job goes overall. All right, guys, we've worked over to the production level of drilling the angle iron. This is Howie. He works over there at D&D Welding, and I've been showing him the setup and how to operate the flex, and he's the one that's going to be manhandling most of this job here. I'm just kind of helping out and making sure everything's running right. We did have to go in and tweak our program a little bit because we were having, one of the angles was sticking up too high, and we started getting a little bit of rubbing on the drill. Yeah, there it goes. It did mess it up. So we had to make an adjustment. What we did, instead of coming down to 0.1 clearance over this, there's so much variation, we changed it so that it rapids down to a 1/2 inch above the part there. So I don't know how much that's gonna add, but I think it's only gonna add maybe a few more seconds to our cycle time. So we did that to ensure we don't crash a drill bit. But everything's working pretty good now. How you feel about it?
Good. It's a lot faster than doing it by hand.
Yeah, that's right. It's a little cooler over in this shop than the welding shop, I'll say that. Every time Joe comes over here, he talks about how cold it is in here. He can't stand the cold. So anyway, this is one stack. There's actually two bundles where Howie cut them in half. I wish I could have got a video of you doing that, man. That would have been totally cool. Putting these in the marble and just making one cut through there. So obviously these are the ones we need to drill. He's got another cart here that he's stacking them up on that are completed, drilled. And once he gets this one bundle done, he's going to take them back over to the yard and then load up the second bundle and get to drilling on them. So as long as we don't have any tool height issues with our workpiece, this should go pretty smoothly. There we go. We just blow the coolant off the tops of them and try to get some of that back down into the machine and unload and reload. Hallie's down to the final 2 on this first stack here. Doing really good. So we have one more bundle sitting right outside, about the same size stack. So I'll go ahead and point this out. We had our first goof up on this one right there. Look at that. Look at that guy. So our drill ended up coming across the top of it, and it got to that point and it snapped it off. Fortunately, I got some spares. So one of the things that I missed with this one right here was that it was sticking up too far for whatever reason, bent. I don't know exactly why it was so much higher, but on our programming, when we first set it up, we only had 0.1 inch clearance above the workpiece when it traverses down to the next hole, all right? And that cut it way too close. So it was right at, obviously it was past that 0.1 of clearance. So what we did is we modified the program, and now we have our drill at 0.5 inches or a ½ inch above the workpiece, so that we know it should clear all of the angle. And we're looking out for any of them that might be sticking way up whenever you go in there. Like this one was a little bit high, but we missed it and it ended up hitting the drill and breaking it. So our ½ inch clearance has proven to be fine, and I think that little bit of difference in movement there is only adding up to maybe a few seconds. In fact, when that one's done drilling, we'll go down there and see what the cycle time is, because we know that when we started, we had them at 1 minute 12 seconds for 2 pieces there. So let's see what our cycle time is now with our modified clearance height of ½ inch. Wait till this is done drilling. I'm going to see what our cycle time is because I haven't looked at it since we modified it. Minute 15 seconds?
15 seconds.
Look at that. So it only changed at 2 seconds then.
Well,
Oh, no, a minute 21.
Yeah, I guess it actually stopped drilling it.
Minute 21. So we actually we added 9 seconds to our cycle time by modifying our clearance height at a ½ inch over the workpiece. Oh, that's me, the laser getting right here. Well, that's the first 2 you were looking for. Now you've only got 1 more stack to do. All right, working out good. All right, second batch in the shop, ready to be drilled. Now he's made it down to his final 2 pieces of angle iron. I'm sure these are the 2 you've been hunting for today, right?
That's it.
So he actually did a count on them, and I had said earlier that I thought it was around 150 pieces, but in fact it's 130 pieces. So I was close. I kind of averaged at what I was looking at in the stack. Final 2, and then this job will be done. Pretty well got the system figured out now, don't you?
Figure it out now that I'm done. Lack of cleanup and the speed of this does, it saved us a lot of time.
Oh yeah. That was it.
That's all she wrote. Off to galvanize.
Yep, that's exactly right. They're gonna, all of them go out to get galvanized, and then from there, you guys are gonna go get them installed on the building, right?
Yep, they're about an elevation of 80 feet and I think 60 feet up in the air on a hangar out at Herbert Field.
Okay.
So we're gonna put brackets and hang reflective panels off of them.
Okay. Well, I'm glad to see it all come to an end. The Flex CNC did an excellent job on this. You know, we had our one little goof up with our drill, but other than that, we really haven't had any other issues with it.
No. Everything went real smooth and definitely, like I said, saved a lot of time.
Yeah.
No cleanup, ready for shipping.
Yep, exactly right. So, all right, guys, this job is done. Really happy to be able to put the Flex to work for a job like this. It's an excellent machine for any kind of production work you want, but it really shines for large work pieces or large and long work pieces, structural steels, things like that, that is harder to do in a more conventional sized machine like the knee mill or a smaller machining center. It's just a good machine for doing this kind of stuff. So I'm gonna give Howie a hand and get this last batch out of here, but this is it. We're all wrapped up and ready to close it up.